let's talk about SQL Server Failover Clusters. So I think there's no surprise for anybody what a failover cluster is, right? It's a set of one or more nodes. And most people think of clusters as two or more nodes, but they actually can be just one. Member nodes can have standalone instances or they can be clustered. This is something that I don't see all that often, but occasionally we do. And as a result, we have a lot of special handling built into the product to manage when you have a node, a server that's a part of a failover cluster that has standalone instances on it that are not clustered instances versus being candidates to hold one or more of the clustered instances within the cluster. And clustered instances, this is one of the key things here. A clustered instance runs on just one node at any given time, right? Hopefully, if you're attending here and this is the advanced session, you already know that. But I'm laying a little bit of foundation work, and I'll talk about why, because once you understand these basics and are reminded of them, some of the pieces that I'll put together here should come together nicely. All of the nodes in a failover cluster are typically in the same location. They're in the same data center. And I'm highlighting this because it's not the case with SQL Server availability groups, and that drives some different behavior for the two, that particular aspect of these clusters. And then when it comes to discovery inside of Actifio, the process looks something like this. When you first run discovery, you're basically going to add a host in Actifio. And when you add the host, and then you run discovery on that first host, what happens is if you haven't added the other hosts in the cluster, they automatically get added. So I don't know if any of you have done this before, where you go into the Actifio user interface and you add a host and it's there, and then you run a discovery, and then you go back and look at your hosts, because instead of having just the one, now you've got a tree structure that shows you the cluster and all the nodes in the cluster underneath it there. The best practice for SQL Server cluster failover clusters is to run discovery on all of the nodes in the cluster. And the reason that we do that is to find those standalone instances, if there are any, as well as to learn about the local file systems versus the clustered file systems on all of those nodes. So best practice, go ahead and add one or more of the hosts in the cluster and then run discovery on that one, as well as then on all of the rest of them that either you've added or automatically showed up. Don't worry, clustered instances won't show up multiple times. They're actually associated with the cluster name. So if I jump over to a user interface, for example, here, and I take a look in my Actifio desktop, and you guys should all be familiar with this. We walked through some of it last week. You know, I've got under the application manager here, under the app tab on the left, organized by data type, under SQL Server Instance, and we looked at this one a little bit, I think, last week, the HQ SQL. If I scroll on down here, you can see I've got a clustered instance. And it's nothing fancy, it's just an example so that I can show a clustered database. But what you notice is that I have the name of the instance, and then I have the name of the cluster. Now, this is important. It's not the name of the listener. It's not the name of the virtual IP for the instance. It's the name of the cluster that the cluster is associated with. And then over on the right-hand side, it tells me which nodes are members of that cluster. So I can see here the cluster name is this Windows cluster, and then the nodes are SQL MSCS node 2 and node 1. Right? So there's the basic structure and how it's organized. If you wanted to search for something, you can of course just type into the search box up here, and when you do, it filters everything out. So immediately I type cluster, I get this instance because it has a database named cluster. If I just typed, it also matched on the cluster name here, Windows cluster. So that's how it gets visualized here in the Actifio desktop. Just like with regular SQL instances, a clustered instance shows up under the list of instances, and you can manage its membership just like any other to say what's included, what's not included. Is it all databases, selected, include, exclude, system user, etc. So there's no changes there. A clustered instance is managed just the same way as a non-clustered instance when it comes time to make decisions about granularity of capture. Am I capturing the whole instance, selected databases with consistency groups, or even individual databases? no changes necessary there. Now, and of course, as always, I'm speaking a little bit ahead of where the slides are going. So when Actifio is configured to discover and then back up from a SQL instance cluster, we have to be aware of the fact that it's a clustered instance, because there are certain tasks that are going to be performed that need to behave differently. So for example, when I run backups, the question often comes up, what do I need to do differently for a clustered instance versus a non-clustered instance? And in this case, running a backup, the answer is really I don't need to do anything different when it comes to cluster disks and cluster resources. For example, as you all know, when we run a SQL Server backup, Actifio actually presents disk to the SQL Server, and then it takes the VSS snap and then it copies the data from the VSS snap onto the Actifio disks. So a reasonable question to ask is, are those disks part of the cluster? Do they have to get added in? Are there any dependencies on them? And the answer there is no. They don't have to be. And the reason they don't have to be is simple. And again, I'm going to try to take the approach of giving the explanation of why at every step of the way, so that if you have additional questions that come up, you might be able to even answer them yourself. And the answer why here is very simple. You look at what are the rules with SQL Server clustering about disk access. And the rule is that any processes running as part of the cluster can only access disks that are also part of the cluster. So if you look at the SQL Server engine, the SQL Server processes that's running, the SQL Server service, it can only access databases on disks that are a member of that cluster. But Actifio is not using the SQL Server engine to do data movement for our backups. Instead, we're taking that VSS snap, and then our connector does the incremental forever copies. The connector is not running as a SQL cluster resource. It's just a standalone service. So it can read the data from the VSS snap, and it can write it to the Actifio mounted disks, and therefore we don't have to add those disks into the cluster. Transaction log backups are actually just the same way. And you might say, well, why is that? Because a transaction log backup actually is SQL dumping the data. And the answer to that one is Microsoft has built into the backup process that a target can be external to the cluster. And it makes sense there too. If you think about it, you can run, even from a cluster, a SQL Server native backup and specify a non-clustered disk as the target. You can specify a CIFS share as the target for all it cares, and a lot of people do. So it makes sense that if we map a disk to the server that has transaction logs on it, and then we're going to run an additional transaction log backup, that disk doesn't have to be part of the cluster either. What about restores and clones? So this one catches people by surprise sometimes, because you would think, well, if I'm going to restore some data, well, that data is being put back into SQL Server. I probably need to have those disks as part of the cluster. And the answer there again is actually no, you don't, because a restore and a clone is actually using, and I'm going to talk more about clones in the availability group section, but they're actually using the Actifio connector to put the data back. And it puts it back onto the clustered disk, but the process that's doing it isn't SQL Server. And therefore, those source disks that we're copying from don't need to be members of the cluster. Mounts are different though. Mounts, we're going to now tell SQL Server to actually run a live database off of some disk. And by its very definition, that disk must be a member of the cluster. Now that means that when we do a mount, Actifio has to be aware of the fact that it's mounting into a cluster, and it has to do things like present the disks to all the nodes in the cluster. It has to add those disks to the cluster with the appropriate dependencies so that the SQL Server instance depends on those disks. And once those tasks are completed, then and only then can we actually bring that database up and online, attach it, roll the transaction logs forward, etc. Now, the interesting nuance here is that the transaction log disks that have the TRN files that we're going to use to roll the database forward, those actually don't need to be members of the cluster, right? Only the data disks, the files, the volumes that have the MDF, NDF, LDF, those have to be members of the cluster. Transaction log, that's more like a restore, than it is a mount. So once the database is mounted and it's in restoring mode, then it has the ability to read from any disk. It doesn't have to be in the cluster. And as a result, we don't add the transaction log disks to the cluster when we do a mount operation. In fact, as soon as the transaction log roll forward is done, like we talked about last week, that disk gets unmounted. It doesn't need to be persistently there in that scenario. Now, all of this brings about a very interesting scenario, and that is dealing with clusters that are running under VMware, virtualized clusters. And the reason it's so interesting is because of some of the requirements that come together to cause some problems, if you will, when you run virtualized clusters. And if any of you have done this, you've probably experienced some of these issues before. So, first off, clusters that are running under VMware have to have physical mode RDMs if you're going to present the storage through VMware at all. You could do iSCSI, for example, directly to the VM, but most people go through the PRDM mode, and then they have their virtual SCSI adapter set for physical bus sharing mode. Now, doing that, and specifically doing that with SQL Server clusters, results in slow reboots and slow HBA scans by default. And there's a reason for it, right? The way that Microsoft has implemented shared storage for clusters, it's important to realize this isn't an active sharing of shared storage, right? You think about VMware and VMFS, where every server in the cluster typically sees the same data stores, and they can all run different VMs on the same data stores at the same time. That file system, VMFS, is designed to be active. Multiple nodes can talk to it at the same time. Oracle RAC, the exact same way. You have these ASM disks, and they're part of an ASM disk group, and ASM is designed to be an active file system almost, where multiple nodes can read and write at the same time, and it manages the locking to make sure things don't step on each other's toes. Microsoft Windows clustering, failover clustering, is not leveraging such an active file system. It can with Hyper-V, but in the failover cluster scenario, it doesn't. And instead, what it does is it says one node is going to own these disks. The node that's running the instance is also going to own those disks, and the other nodes aren't allowed to touch it. And in order to enforce that, what Microsoft does is they take a persistent reservation, meaning an iSCSI reservation, or a SCSI, sorry, reservation on each disk in the cluster, and they hold it reserved. Now, a disk that has a SCSI reservation on it from some server is completely inaccessible from any other server. You can't do anything with it. And so what happens in VMware is you have these physical mode RDMs presented to a VM, to say 2 VMs in a failover cluster, and one of them is actually running the instance. So the one that's running the instance has a SCSI reservation on it for all of those disks. The other VM in the SQL cluster is almost always running on a different physical VMware node. In fact, you set affinity rules in VMware to guarantee that. And of course, it makes sense. You don't want both nodes in the cluster running on the same piece of hardware. That defeats one of the main purposes of the cluster, and that resilience to come up right away again and to do a failover. So what happens is every other ESX host in the VMware cluster sees those PRDMs, they see the disk devices, but because they have a SCSI reservation on it, they're not able to scan it. And when they can't scan it, they try, but they time out. That timeout can be fairly long, can be 30 seconds, can be 60 seconds. I forgot what the default is, but it's not really fast. And as a result, every time you do HBA scanning on any node in the cluster, in the VMware cluster, it times out and takes a long time. The more disks there are, the longer it takes. And VMware also does that same scanning on a reboot of an ESX host. So the solution to this is to use a setting that VMware introduced not that long ago called Perennial Reservations. Perennial reservations mean you're telling a specific VMware host that a specific disk is going to have a persistent reservation on it. don't try to scan it. Just don't even bother. You know it's going to time out. Don't worry about it. Ignore that disk when it comes to time to scan. So for customers who have deployed the SQL Server Failover Clusters under VMware, hopefully you've all set this setting. If not, just Google Perennial Reservations VMware and you'll find the KB article on how to set them. But setting them is actually kind of tedious. It has to be done on each ESX host for each disk. And if you unpresent that disk and represent it, it has to be done again. And it can't even be done through the VMware APIs. So as a result of all of this, Actifio does not support mounting into virtualized clusters for that exact reason, because we don't have the ability to set those perennial reservations. We've actually had some discussions with VMware about them adding it into their APIs or allowing us to bundle in like ESX CLI, which is one of the ways that you can set them. But for licensing reasons, they don't allow you to redistribute that code. So right now we're kind of stuck without a way to actually do it. And therefore we've disabled. We actually did all the coding work to support VM clusters hosting SQL clusters, but had to disable it for that specific reason. The good news is that the trend is not to run SQL Server clusters anymore under VMware. I know there are probably some of you out there who do it, but what I've definitely seen in my customer install base and my customer interactions is that people see the complexity of failover clusters as a big stopper towards wanting to continue to use them. And instead, as they virtualize all but the largest of their SQL environments, they're leveraging VMware HA instead. And most of the comments that I hear from the customers is that the complexity with VMware HA is so much less versus a SQL failover cluster, and the recovery time is very, very close. It's booting up the VM on another host, so it has a little bit of boot up time, which isn't quite as fast as a failover cluster failover, but there's still an interruption. And so if it's 2 minutes instead of 1 minute, it usually isn't a big deal, and it's worthwhile for the reduced complexity. The other approach that customers are taking more and more is to start using SQL Server availability groups. So before I go there's a couple more things on clusters that I wanted to talk about, because this is one of the reasons that you wanted to probably tune in. So advanced options for backups for SQL Server clusters. The answer is there really aren't any that you need to use. You don't use service access point IP, and I'll talk about what that is and when you do use it. But for failover clusters, you really don't need to do anything special. You discover them and then you protect them just like they're standalones. The rest of the work should all be done automatically by Actifio for you. Jobs will always find the active node. It will use the shared IP address of the instance in order to locate where is that SQL instance running, and then it will connect to the appropriate node. So when you have failover clusters, a lot of people ask the question, well, what happens when I have a failover? How does that impact backups? What's any risk there? The answer is that Actifio detects when there's a node failover in a SQL failover cluster, and it takes certain actions to automatically adjust. One of them has to do with staging disks. So you all may know, and if not, I'll show you real quick here, in the user interface, under any snapshot policy. So if I just come to some snapshot policy and I dive in here, there's an option along the right-hand side here called Do Not Unmap. And the options in here are to keep staging disks mapped between jobs or to unmap staging disks after each job. And a lot of people don't always pay attention to this option, but it is kind of an important one, and it has some repercussions. If you say keep staging disks mapped between jobs, what it means is that disk that we back up onto remains visible to the server even in between jobs. It doesn't remain mounted. You don't see any drive letters or mount points that give you access to it. But if you looked in Device Manager, you would see the disk devices. Now, the reason people do that is because it makes the backup jobs run faster. If you don't have to present the disk, scan for the disk, and then assign it a mount point, and then at the end, remove them, and not just remove the mount point, but remove the disk and then rescan to confirm that it's gone, that makes your jobs run a little bit quicker. On the other hand, leaving it mapped all the time also consumes towards your maximum disk count, which servers have. So for very large environments, usually people don't leave the disks mapped. For intermediate sized environments, they do. And for very small, they tend not to because the amount of time for mapping 1 or 2 disks isn't such a big deal. So it's kind of an interesting setting. But we were just talking a minute ago about perennial reservations and about iSCSI reserves, right? Well, and the reason for them is to prevent having multiple nodes trying to write to the same disk at the same time. So what we have to do is we also have to prevent that from happening, keeping in mind that NTFS isn't an active file system. So if you have that set to say leave the disks mapped in between jobs, and then you have, for example, a node failover to a different node, well, now the disks are mapped to a different node than the one that you're going to run the backups on. And if on the next job we simply mapped the disks to the new node and left the old ones mapped to the old node, well, now you've got them mapped to multiple places and they're not managed by the cluster, so there's no SQSI reservations. Now you have some risk of corrupting those data volumes. And we've seen it happen when the server that has them mapped but doesn't have the instance gets rebooted, for example. Sometimes it'll come up and it'll try and automatically assign a path to those disks and bring them online, and then it'll detect that, no, wait a minute, they're online on another drive, and you get into this cycle with the two servers fighting for it, basically, and ultimately corrupting the disk volume. On rare occasions, we've even seen a server reboot or go into a reboot loop trying to reconcile what to do with those disks. So when we run a job, we always make sure we unmap the staging disks from any non-primary nodes. The other thing we do during a failover is we maintain change block tracking. So change block tracking, as you know, it's done with this bitmap, and the bitmap is really in memory, keeping track of all the changes that take place. So it makes sense that if a node failover occurs and a SQL Server instance moves from node A to node B, and then after that, you try to run a backup job on node B, well, how does it know about the changes from node A? And the answer is we've built into the connectors to share that information with each other. So the connectors actually talk directly to each other in order to share that bitmap information, so that when you run a job on node B can talk to node A and get the list of changes that happened while it was on A, combine that with the list of changes that happened while it was on B, and then continue to do a change-only incremental block level backup. So that's a feature relatively new. I think we added that in the 8.0 timeframe. Maybe a 7.1 higher version service pack is when that came out.
Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.